Alright, problem number 17, it says if BCDE is congruent to OPQR, then BC is congruent to blank, and we have to fill in the blank. So this is, again, a congruent statement, and in congruent statements, if BC occupies the first two spaces in the name, and OP occupies the first two spaces in the name, then they are congruent, and I can put OP in that space. Problem number 18, this is the sum of two segments, EF plus FG. Right, so this is the line segment postulate, right? Addition postulate. So EF plus FG should be equal to EG. And so if I plug in the information that they gave us, they said that EF is 2x minus 14, FG is 3x minus 15, and EG is 26, and now I can solve this one for x, right? So if this looks like 5x, when I add together the 2x and the 3x, and I get negative 29 is equal to 26. If I add the 29 over, I get that 5x is equal to, looks like 55, and that means that x has to be equal to 11, right? So that's the first answer, is what is the value of x. EF, I would have to take that 11 and plug it in right here, so I would do EF is equal to 2 times 11 minus 14. Well, that's 22 minus 14, which is 8. And then for FG, I don't even have to do the plugging in, because I know that the total is 26, and I know that EF is 8, which means FG has to be 18. So that's a good check. If you go plug in your 11 right there, you better get 18, or something went wrong and you're not getting a total of 26. Problem number 19 is saying find the area of a triangle. So we've done some of these already. 1/2 base height. Well, the base is 6.8, so 1/2 of 6.8. And this 9, even though it's not the line of the triangle, it is the height of the triangle, so I would say 9. Right, so again, this is just, let's go to the calculator because I have a decimal and I can't do that one in my head. So we'll say 0.5 times 6.8 times 9. So that would be 30.6. So I'd say the area, okay, is 30.6, and the units would be centimeters squared, right? Because it's an area. Problem number 4, very similar. This is the area of a parallelogram, and that one is just base height. And so my base in this case is 27, so I'm going to say 27, and my height in this case is 21. So I'm going to say that this is 27 times 21, which again on my calculator, okay, I get 567. So I'd say the area is 567 square inches. Okay. Problem 21. So this is saying F is parallel to G, and so this is really getting to this picture. I know that you've seen this before, right? Where we said these angles that are in between parallel lines are supplementary. They're called same side or consecutive interior angles. So we can say these two fit that same description. We're just going to say that 2x plus 6x plus 28 has to be equal to 180. And so that's 8x, right? 8x plus 28 equals 180. Oops, equals 180. And then if I subtract the 28, I get that 8x is equal to 152. And then if I divide by both sides by 8, it looks like I get 1, and then I get a 7 left over, so 19. So I'd say x in this case is equal to 19. And let's make sure that that's what they asked us for. It does say find the value of x, so we've done what they asked. Okay. Problem 22, it's saying find the lateral and surface area of the prism. So to remind you about those formulas, again, they will be provided to you. Lateral area is PH, where the P represents the perimeter of the base. And so this one's the trickiest one, because the question is now, which of the rectangles is the base? And the answer is really, well, any of them can be, because it's a rectangular prism. So I'm going to choose the bottom of the shape, which is this one right here. All right, so I'm going to say this one, and again, just excuse my straight line drawing. It'll fix it for me. Okay, so this one right here I'm going to use as the bottom, as the base of my triangle, and then obviously there's one above it, right? So we're going to say, what is the perimeter of that shape? Well, that looks like it's got a length of 16, which means that the back right here is also 16, that's 32, and I have an 8 along the side, so that takes me up to 40, and another 8, which means my perimeter is 48, right? And now the H is the height of the prism, so how far is it from the bottom base to the top base? Well, that's what this line 3 is doing. It's connecting the bottom and the top. So if I multiply these together, it looks like I get 144, right? So I'm going to say the lateral area is 144 meters squared. So that's part 1. What is the lateral area? The surface area, which again, formula will be given to you, is LA plus 2b. Well, lateral area we have, that's 144. Okay? And then the capital B represents the area of the base. So I have to look again at the same 16 by 8 rectangle and say, what is the area of that? Well, that's just length times width. Okay, so let me get 16 times 8 times 8 would be 128. So this is 2 times 128. Okay. And now if I just add this together, this is really 256 plus 144. And that makes the surface area 400. Okay. So my overall surface area is 400 meters squared. Problem number 23. It says find the circumference. So circumference is equal to pi d. It asks us to leave our answer in terms of pi, so they're really just saying plug in the diameter, which for us is 7.1 pi centimeters. And that would be my circumference. Okay, so pretty straightforward. They're not all going to be crazy challenging. Okay, so problem 24 is again that picture of parallel lines and what we know about equality and supplementary angles in parallel lines. So if my angle P is here, what I'm going to do is I'm going to move it everywhere that angle P could exist. So it could exist here because of vertical angles. It could exist here because of corresponding angles, and it also could exist here because of alternate exterior angles. So the one I'm going to use is actually this one, and I'm going to say these two are right next to each other, and that's that supplementary situation. So angle P plus 97 should equal 180 because they are same side interior angles between line J and line K. So if I subtract the angle 97, it looks like I'm left with 83. So I'd say angle P has got to be 83 degrees in order to have supplementary angles in between the parallel lines. Okay, problem 25. So problem 25, they're asking us to find the area of the shaded region. So that is this black space in the middle here. And so we have to kind of figure out what's going on and how we're going to kind of use what we know about circles and squares to find the area of the shaded region. So what we ultimately want to do, again, let me grab my highlighter so we can talk about it, or see it as I talk about it. This rectangle, or I'm sorry, this square contains the shaded region. So if I can find the area of this, okay, but then remove from that area all of these little circle pieces that we don't want, well, it looks like now the leftover is the shaded region. So let's start off with finding the area of the square, right? And so we have to think about, well, how long are one of these sides on the square? And the only thing they tell us is that out here is 4. So we think about the circle, right? If this little piece right here, okay, and then I have another one of those, right? And it looks like I have a duplicate circle up here, right? That's 3 now, and there's 4, right? So I have 4 radius lines going from the bottom circle, the bottom of the bottom circle to the top of the top circle. So they each have to be worth 1 to go all the way to the bottom. So this little space here from B to C is then worth 2. So the area of my square has to be worth 2 times 2, because this way, same thing, right? There's a radius of 1 and another radius of 1, so it's got to be 2 times 2, which is 4. So this whole space right here is 4 square inches. And so now I got to think about these circles. So here's what I really did. If I take one of these little spaces, right, these little circle spaces here, and then I took the other ones, right, this one right here and this one right here all the way around, and I put them together, I'm actually getting one whole circle that has a radius of 1. So if I find the area of a circle that has a radius of 1, I'm going to do pi times 1 squared, which is just 1 times pi or pi, right? So I'm saying the area of all of this space, which represents one whole circle, right, because it's 4 pieces, 4 quarters of a circle, which is one whole circle. If I now take the whole square and subtract off the circle area, what's left over is the shaded region. So this answer right here, 4 minus pi, represents the area of that little black space in between the circles. Okay? Problem 26. They're asking for us to describe the possible sequence of transformations to go from A, B, C, then to A prime, B prime, C prime, and then to A double prime, B double prime, C double prime. So we're starting with this blue one. Right, and from the blue one, we're going to move down here, and then from the red one, we'll move over to this kind of maroon-colored one. So the question is, well, how do I get C to go from here to there? And then B goes from here to here, right, and A goes down. So it looks like they're just being reflected over the x-axis. So we're going to say that's our first transformation. I'm just going to say reflect, okay, over the x-axis. Okay. So that's transformation number 1. And now the question is, well, how did I take B and go all the way over here, and then C goes all the way over here? A goes all the way over. Well, it looks like they're all being moved to the left by a certain number of units. So let's just check that it's the same number of units. And let me get rid of all these extra lines. Right, so I'm going to count how far is it from C prime to C double prime. So if I go 1, 2, 3, 4, 5 to the left, if all of the rest of them go 5 to the left, that's my answer. 1, 2, 3, 4, 5 to the left, and the last one, 1, 2, 3, 4, 5 to the left. So I'm going to call this one translation. That's what we mean sliding left and right to the left, okay, by 5. Okay, so those would be my two transformations that take ABC to A double prime, B double prime, C double prime. Problem number 27. So 27 looks like it's got a 30-degree angle and a right angle, so that's a 30, 60, 90. And so we're going to use what we know about 30, 60, 90s, which is that the short leg, which is this y, it's across from the 30, is always half of the hypotenuse. So y has to be equal to half of 18 root 3, which is 9 root 3. Okay, so let me get rid of that and put the correct number there, 9 root 3. And then if I take the 9 root 3, which I'm going to do the work for this off to the side, this is the short leg, and I multiply it by another square root of 3, that should give me the long leg, which in our case is x. So again, square root of 3 times square root of 3 is going to cancel out the radical and just leave us with 3, right? It's the square root of 9, which is 3, okay? So that looks like x has to be 27. So it's its simplest radical form. We're good to go. Okay, problem number 28, and we're going to use this again for 29, uses geometric mean. And here are the rules for geometric mean. We said that the altitude is the geometric mean. So let me actually put it on the bottom. I think that's where we usually keep it. So we're going to set up two fractions. Okay, and we said the altitude is the geometric mean, which means it's going to go on the means, right here, of the segments, which I use segment 1 and segment 2 to represent the pieces that were created. When I drew this altitude in, okay, to this right triangle, I created the 21 in the A. It used to be a whole hypotenuse. Now it's two pieces of the hypotenuse. So if I plug that information in, I'm going to say, okay, 20 is on the bottom, and it's also on the top over here because they are both the altitude. And then I have a 21 as one of the segments and an A as the other segment. So this looks like 400, okay, when I multiply one direction, and 21A in the other direction. So if I divide both sides by 21, you get about 19.04, okay? So this little piece here, instead of calling it A, let's call it 19.04, and that means that my whole hypotenuse is about 40.04. So to find B, you have two options. You could just say Pythagorean theorem. Let's forget about this altitude. Let's say I have a hypotenuse of 40.04 and a leg of 29 and use the Pythagorean theorem to find B. Here's your other option. Okay, so I can use this other rule that says that the leg is the geometric mean. So I'm going to place leg in the mean positions, okay, it's of the segment that's closer to B, right? So if this is my leg, if I go right around the corner, right, I get the closer segment. So I'm just going to put segment 1 for now. We'll call this leg 1, okay? And then the whole hypotenuse is the other piece, which for us we said was 40.04. So again, if I plug in what I know, the legs are going to go here, okay, like that, okay? And then I'm going to place this closer segment right around the corner, which is the 19.04 that we just found, okay? And then the whole hypotenuse, which is 40.04, which is going to go right there. So if I cross multiply here, I get B squared equals, right, and I'm going to go to my calculator and do 19.04 times 40.04, which is 762.36. So we'll say 762.4. Okay? And now if I square root both sides, I get about 27.6. So B has to be 27.6. And in the context of our problem, that looks like an entirely reasonable value, right? The hypotenuse is 40, right? So it's definitely not bigger than the hypotenuse, and it's right around the same length as the other leg. So that's an entirely reasonable value, okay? So I'm not going to do letter B because this one is entirely identical. Just plug in those numbers instead of the ones that we had. So I'm going to skip over letter B here, okay? So problem 29. Find the measure of the numbered angles in the rhombus. So again, back in chapter 6, we got lots of information about parallelograms. So for a rhombus, here's the two key pieces of information. The first one is that diagonals make right angles. So I can say that angle 1 has to be 90, okay? And all of these other ones are also 90, which we're going to use one of them, okay? The other rule was that in a rhombus, when you draw a diagonal, you bisect the angles. So if this was 12, the one right next to it also has to be 12. Right? And then a parallelogram rule says that opposite angles are congruent. So if this angle is 24, This one down here is also 24, and it's made up of a 12 and a 12. Right? So I found out angle 2 has to be also 12 degrees because of properties of a rhombus. And then angle 3, if you notice on this right triangle here, I know a 12 and a 90. So if you find the rest of the 180, it looks like that's got to be 78 degrees. Okay, so 78 degrees represents angle 3. Okay. Problem number 30. Right, so again, I think we've seen something like this before in video 1, where we said this is parallel lines, right? And when we drew in this parallel line to the third side, we created segments using the other sides. So I'm going to set up a fraction that's x over x plus 5. So the segments on the left, and then the segments on the right. Okay, so this one's a little bit more algebra, because when I cross multiply, let's do the easy one first. X times x plus 1 is x squared plus x. When I multiply together x plus 5 and x minus 2, you have to FOIL it out. So I'm not going to actually do that. That's something you should be able to do. I'm going to say x squared plus 3x minus 10 is the product of these two expressions. So if you need to, off to the side, actually multiply it out and combine like terms, go right ahead. Okay, but you should get x squared plus 3x minus 10. Okay, so I'm going to start combining terms. I see x squared here and x squared here. So when I subtract this x squared, the nice thing that happens in this problem is the one on the left also goes away. So here's what I'm left with. X equals 3x minus 10. I'm going to subtract the 3x over, get negative 2x equals negative 10. And so that means that x, it looks like it has to be 5. That would be my answer to problem 30. Okay, a couple more to go. Here's problem number 31. So your answers to this: supplementary angles always add up to 180. Okay, and complementary angles always add up to 90. And the way that I remember that is the letter COMP. You could actually draw a quick line right here, and you get a 90 right at the beginning. So that's how I keep these two straight when I'm trying to remember the difference between them. Okay, last problem on this video. Okay, so this one says the sum of the interior measures of a polygon with side S is 2520. Find out what S is. So again, this is that whole formula of 180 times, I'm going to use their letter. We usually use n minus 2, but I'm going to call it s minus 2 because that's what they used. This is going to give me the sum if I know the side. Right now we're trying to find the side, but I already know that this should be equal to 2520. So to solve this one, I'm going to divide both sides by 180, and I believe when you do that you get 14. Okay, so if I divide both sides by 180, just get rid of this right away. You could distribute it, but I don't want to. I just want it to go away. So I'm going to say s minus 2 is equal to 14, and if I add the 2 over, that means the number of sides has to be equal to 16. So this is a 16-sided polygon to have a sum of for the angles of 2520.